Hello, today we're going to be talking about sequences and series. This is usually a point in your calculus journey where the rigor usually steps up, mathematical rigor, and this is also a point of passage for many students because this is usually where they will become uh, not as motivated in their studies, but it's important to just practice and to study very much. Today we're just going to be talking about sequences and series and an introduction to them. So we have to first remember what is the sequence? What is a sequence? And versus a series. What is a series? What is the difference? And so the main thing to remember is that a sequence, I'm just going to talk about sequences first, is a set of numbers uh, with an order. Okay? So, um, you know, one that you've probably seen is 1, 2, 3, 4, 5. It can be anything really. It can be every number. We can also take a limit of a sequence. Okay. And so with a sequence of A of n, oh, and we usually write a sequence as A of 1, A of 2, A of 3, and so on, all the way to like A of n. So with A of n, which is our sequence, we can consider, so with A of n, our sequence, we can consider the limit as n approaches infinity of A of n is equal to some limit L if the distance between L minus A of n is less than epsilon, for any epsilon greater than 0, provided that n is large enough. All right, and epsilon is a really small number. Um, and so that was not very intuitive. It doesn't really make sense. It's kind of like the definition of a limit that you did in Calculus 1. So a good thing to do is just to hop into an example. So given a sequence, n plus 1 over 3n minus 5, just some random sequence, and we start plugging in numbers, right? If we plug in n is equal to 1, we're gonna have 2, and then we're gonna divide 3 minus 5, which is gonna be negative 2, right? That's our first term. So then our second term, if we plug in n is equal to 2, we're gonna get 3 on the top, and then we're gonna get 1, right? And then we're gonna get 4 over 4, which is 1. We're gonna get 5 over 7, I think, and so on. And so, what is the limit of A of n? Is lim as n approaches infinity, A of n. So you probably know how to do this from Calculus 1, and it's very simple, but it's important to get the basics down. So if you have n plus 1, and you have 3n minus 5, and if you're a computer scientist, you know this, is that you look at the order of growth, okay? And so the order of growth is linear, or I mean technically it's not linear. It's on each numerator and each denominator. You can look at the order of growth. So the order of growth is n in the numerator and n in the denominator. So usually you divide by that order of growth on both sides, or on top and bottom, and then you're going to get the limit as n approaches infinity of 1 divided by 3 times 1 over n plus minus 5 over n. And these are going to be really small numbers as n approaches infinity, and so you're going to get 1 over 3. Okay? So that is your limit. So that means that as we get so many n's, we plug in, I don't know, an infinitely large number or something. We're going to eventually get closer and closer to this 1 over 3. Okay, so we familiarized ourselves with a sequence. Now, what is a series? What is a series? So a series, it means a sum. And I don't know who named it. It was probably a really stupid idea to name it a series. Because it was probably a good thing to just call it a sum. So a famous series that you might know or you might not know is 1 plus 1 over 4 plus 1 over 9 plus 1 over 16 plus 1 over 25, right? Plus dot dot dot, right? So what is this? This is actually and we're going to use sigma notation from now on. K is equal to 1 to infinity, and we're going to do 1 over k squared, right? That's what it is. Because, see, 4 is 2 squared, 9 is 3 squared, 16 is 4 squared, and so on. And so this was actually figured out by a man named, what was his name? His name was Leonard Euler. And he figured out that this series actually converges to a point. So if you would imagine adding up all these really, really tiny numbers, they add up to pi squared over 6, I believe. Yeah. So he figured that out, which is pretty remarkable of him. Okay. So another series that you might be familiarized with is it's called the harmonic series, and it's 1 over k. And so this is going to be equal to like 1 plus 1 half plus 1/3 plus 1 over 4 plus 1 over 5th plus 1 over 6. And this, you might think, well, what does this add up to, right? This one's pi squared over 6. This one is what? This one does not converge to a point, so we actually call it divergent, which means it adds up to infinity. Infinity is not a number, but it grows beyond what we can figure out where it converges to. So it grows too much. So this diverges. Alright. And so it's important to remember what diverge and converge means, especially when you talk about this unit of study. Let's do another topic. So there is also something called the geometric series. And so the geometric series is a series where you have some multiplier, and usually sometimes it's 1, but it can be some constant, like, I don't know, I'm going to call it g maybe. Some constant g times some ratio to the kth power, where k is the thing that's being iterated. And so this is called the geometric series. I mean, it's not a specific series, it's a type of series. As in, some things can be geometric, but all geometric series are all series, right? So, one example might be, it could be, I don't know, 9 times 1 over 10 to the k power, right? And so, if we plug in 1, we're going to get 1 over 10 times 9, right? So that's going to be equal to 9/10. And then we're going to get 9 times 1 over 100, right? For 2. We're going to get 9 over 100, and then we're going to get 9 over 1,000. And you can see how this becomes really, really small really quickly, right? And that's because the exponent is doing a lot of work. And so really what this is 0.9 plus 0.9, or 0.09 plus 0.009, and then there's a bunch of zeros, and it keeps going. So actually this is equal to 0.99999. Repeating. Right, and this is actually equal to 1. Right. Okay. Let's do another one. 1 over 2 to the k power, right? And so if we plug in 1, we're gonna get 1/2 plus a 4th plus an 1/8 plus a 16th plus a 32nd, and this is equal to 1. And it's pretty difficult to understand this at first. And so I think the best example to understand this is if I have a room, if I was walking in a room, and this is the wall, right? And I'm walking here. If I wanted to get to the end, right here, and I'm at the start. If I walk halfway to the room, I'll be right here. All right, I'll be right here. And then if I walk halfway again, which is a 4th, I'm gonna get right here. And I walk halfway again, get right here, and that's gonna be an 1/8. And then I'm gonna walk right here halfway, and that's gonna be 1/16, and then a 32nd, and then a 64th, And you can see how eventually I'm gonna get really close to the end of the room. I'm actually gonna get to the end of the room, uh, if I do it infinitely many times. Um, so that's why it converges to one, because it's one full room. Right, this is one. Okay, so I think this video is nearing about like 13 minutes, so I'm gonna stop the recording. But this is a good introduction to the concept of sequences and series. Goodbye.